So this is section 2.3, and we're going to talk about multiplying a matrix times a vector. And it turns out that we use the dot product. So we are going to focus on the rows of A, because when I multiply, the first component of the vector product is going to be the dot product of the first row of A with the vector. Okay, so what's the dot product? Well, let me show it with a couple of simple vectors. So I've created the vectors x and y, and let's execute this code block so that the computer knows what they are. And then when we come down here, and let's just go dot x comma y. So dot is the MATLAB function for the dot product, and it says the answer is 5. So let's talk about what's going on here. So what it does is it takes the first component of x times the first component of y and multiplies them, right? And gets 2. 2 times 1 is 2. Then it takes the second component of x times the second component of y and gets 0. And then we're going to do that for all the components, and then we're going to add them up. We're going to add all the products. Then I have a 3 times 1 is the last product, so 3 times 1 is 3. And when I add up 2 plus 0 plus 3, I get 5. So that's the dot product, and you can see with slightly bigger numbers, let's throw something in perhaps like this and a -2, right? And you'll see that when I do 1 times 2, I get 2, and I do 4 times -2, so I get a -8, and you'll see that when I do an 8 times 1, I get a +8, so 2 minus 8 plus 8 does in fact equal 2. So that's the dot product. By the way, it doesn't matter. The dot product doesn't care if we have row vectors or column vectors. Row vectors and column vectors are the same thing. So I'm switching x here to be a row vector. And notice that the dot product still works just fine. If I put 10 in here, right, the dot product is 4. And so here we have a row vector, and here we have a column vector. There is no difference. And as a matter of fact, we can use the transpose function, which is just the single quote at the end, and that will turn a row vector into a column vector or a column vector into a row vector. But it's important to know that a vector in R3, like this one, right? This vector here in R3, right? You find the location of the tip of the arrow by going 1 unit along the x-axis, 4 units along the y-axis, and 10 units along the x-axis. The z-axis. So that's true whether I have a column or a row. All right, so don't let the distinction between row vectors and column vectors confuse you. It doesn't matter. It only matters when I do matrix multiplication, and we'll talk about that later. As long as I'm using the dot product, I can have any configuration of row vector times row vector times column vector, or 2 column vectors times each other. Okay, so now let's go back up to multiplying this vector times this matrix, okay? So what I want to do is I want to do the dot product of row 1, right, with V. So I want to do this row 1 vector, and dotted we just use a solid dot with V. And then the second component is going to be R2, the vector R2, dotted with the vector V. And this is getting tedious trying to write with the mouse, so I'll quit and show you what we're going to do. So I can create row 1 by just saying, hey, give me the first row of A, right? 1 comma colon says, hey, I want everything in row, I want row 1, and then the column just iterates along, the whole top row and grabs me the whole thing, okay? And I'm going to do that same thing for rows 2 and 3, but I'm going to copy paste. And that'll be a 3, and that'll be a 2, and then also rename the vector. So now I'll have row vectors R1, R2, and R3. And so let me just show what's going on first. So if I just want to, I want to do dot R1 comma V, And you can see that that's going to be 42. All right, and I'm going to do that a couple more times, except now I'm going to do it for R2 and now for R3. Okay, so now I know that my vector is equal to these components, right? Its first component is the dot product R1 of R1, the first row in V, and its second, sorry, I'm creating a column vector here, so let me put a semicolon. Its second component is R2 dotted with V, and its third component is going to be the third row dotted with V. And I've messed something up. You were probably telling the video that those needed to be square brackets, right, to let it know that I'm creating a vector or a matrix. And there you go. Wait, this is supposed to be a 2 here, so then yes, everything matches, right? The dot product of the first row in V is 42, and the second is 15 and 58. So I am getting the correct vector here. Okay, and we can just check that by multiplying A times V. Sorry, V. Wait. So I made kind of a silly mistake here. I was calling this vector. This is the component V1, right? So that's the first component. I'm sorry. This is some other vector, right? So if I'm taking A times B, A times the vector V, what we're getting is we're getting the answer, right? So what I was actually creating when I was saying V was actually the first component of B, right? The solution when I multiply them together. So I kind of screwed that up there. And so what I want to do is I want to say that B equals this dot product. Now when I re-execute it, I'll set V equal to this, right? And now B is my solution vector, which is the 42, 15, and 5. And notice now that when I multiply, I just use the multiply symbol in MATLAB, then I get the same thing. So we are now demonstrating that for this matrix and vector that I just dot row 1, row 2, and row 3 with V respectively, and then those are the components of the vector B. Okay. So here's another setup. Here we have a 3x4 matrix, and so notice that the number of columns, right, 1, 2, 3, 4 columns, is the number of components in my vector, and that has to be the case. Otherwise, I'll get a dimension mismatch. For example, watch if I add another component to X and try to do A times X, I'll get the dimension error, incorrect dimensions, right? Okay. So let me take that out. This is the example from the book, as a matter of fact, and just showing here that we can do the exact same thing. I've created rows 1, 2, and 3. So we are going to end up with a vector, say y, that is equal to what? It's going to be equal to the dot product of row 1 and X, and then dot product of row 2 and X, and then the dot product of row 3 and X, right? So let's look at the connections here between these vector equations and matrix equations, right? So if I actually solve, first of all, I should be able to do A times X and get Y, which is good. But let's do this, right? If I have this matrix equation, A times the vector X equals Y, and I know y, then I can create an augmented matrix, right? I can augment the matrix A with y and row reduce it to find x. So let's try that. So let me just RREF the augmented matrix A comma y. And this is not what I was expecting. I guess we would have to solve, and I'm gonna have to do rats on that just to see what the yeah, so that's looking pretty ugly, and I'm not sure that I'm going to solve it right this second, because we have a free variable and there's some vectors to do. So I should have picked a better example, perhaps. And I'll have to fix that online as well. I thought I had one that was working, and I have not been able to edit or create anything online. In that book, there's been an update to the software I'm using to create those, and it's created some version conflicts, and I will get that fixed online as soon as I can. But this is how you do it, um, and again, we would need to do some solving from here. So just understand that this is how we multiply a vector times a matrix.